like to introduce the person who probably needs the least amount of introducing, because anybody who's been delving into the world of DCC over the last several years would know the name of George Bogatuk from who's sales and support at SoundTraxx. So George has modeled since the age of 14. So that means he's been modeling for what, 8-10 years, something like that, George? He models Missouri Pacific in 1978. We won't hold that against him. He's been working at SoundTraxx for the past 14 and a half years. I really made note of the half year there, because that's like when we ask a kid how old he is, they always say, well, I'm 6.5. They never tell you they're 6 or 7, right? So George is actually keeping count of the half years. And he's learned so much, was not out in the public, that he wanted to share his knowledge to help make DCC easier for the users. You can massage it to make it sound great. So, George, it's over to you. And I'm hoping you can see that I'm going to be running the slides, because apparently some yo-yo in Durango cut the fiber line, and George doesn't have any internet, so he's on the phone. And I'm running his slides from my computer in Canada. So it's truly an international presentation we're having tonight.
Yeah, I'm doing this by phone. And so you might be able to see me because I'm doing it on my cell phone. But I didn't have any way to share the presentation. So, Jerry, I appreciate you being able to do that in the last minute scenario.
No
but anyway, so I've got a lot of stuff here to cover, and I'm going to try to be quick but thorough, because I think, when we all talk about DCC, people who are new in the hobby or people who are coming into the hobby really hear DCC and they hear digital and they just panic. And what happens is a lot of people will attribute more to what's happening than what is actually happening on the rails. And so in our community, we have people around in the various hobby aspects, whether it be a club environment or a local round robin group, things like that, where somebody's figured out how to run a train and they become the DCC guru, which term drives me absolutely nuts, and I'll save that for another time to explain why. But I was that guy in my train club back in Texas. Mark, I know you're familiar with the Spring Creek Model Railroad Club down there in Dallas, Fort Worth, where I'm originally from. And in that club, I was the guy that everybody came to with questions. And I came into, and so when I moved up here and started working for SoundTraxx, I realized I didn't know jack squat. And so one of my biggest goals is to try to get a lot of information out, because when it comes to running our trains, if we're afraid of the technology or we're afraid of the user interface or whatever the case is, it makes our trains not as much fun to run. And so because of that, now we're finding out, like, for example, I have talked to people all the time that they're afraid to set a CV value wrong. And we'll get into the definitions and everything. But they're afraid to set a CV value wrong because they're afraid that you can't undo what they just did. And so, but I'm here to tell you that there's a lot more, especially with the SoundTraxx product, there's a lot more safety nets and cushions built into the products. It takes a lot to break it, but let's talk about the basics of it and understand what's actually happening on the rails, so that you can understand what all's going on. Because as they always say, knowledge is power. And when you know what's happening, you're not afraid of what's happening anymore. And so now you have that confidence to go in and enjoy your trains, and you go in and set up and make changes. Because I take my trains whenever I travel to different shows, I'll take my stuff and run them on different club layouts. Everybody comes over and tells me, oh my God, that stuff looks and runs so well. And I just say, I'm not doing anything you can't do. It's just, I live this every day, so I know it. And so I'm here to share that information. So let's get into this. The digital advantage, the DCC advantage. When we started in the world of DCC, at that time, there were a lot of different variable or proprietary command control systems. We've all heard of, my brain just went blank. There's Rail Command was one of them. There's Dynatrol and some of these others. And what happened was, if a proprietor of that company had health issues or wasn't making enough and decided to call it quits, your entire investment's gone. And so what the company and the NMRA got together, the companies that we all got together in a blue moon scenario and kind of created the DCC standard. The NMRA owns the standard, and it is an industry standard. And what that does is everybody's stuff will work with each other's stuff when it comes to the rails. The only standard that is really standard for is the command on the rails. Everything that make the command on the rails is proprietary to the manufacturer, and how that signal is interpreted by the decoder is then proprietary to the manufacturer. But what happens is that the DCC system creates the signal on the rail, and anybody's decoder can receive that command and run. So like, say, for example, if this company that's out there that's designed in Germany, built in China, and sold out of a guy's house in Pennsylvania happens to go away, well, you can just buy SoundTraxx decoders because we're here for the long haul. So you're not out any investment or anything like that. And because it's all standardized, there's a large knowledge base, one technology fits all scales, and you have a high degree of functionality and a superior signal. I mean, you can do a lot of stuff with DCC that you couldn't do before. But what it does, we'll go to the next slide. What it does, it makes our trains more fun, because now we can actually almost feel like we're running the real locomotives. And instead of running sections of track like we used to do in DC, where you turn toggle switches and turn on and off sections of track to now run your train on, the commands are being sent out to talk to the locomotives and tell it what to do. So going back to the presentation before with the Ship It software, now we can run our trains. We don't have to run sections of track. We don't have to worry about, well, is that industry siding on that I can get onto, or worried about disturbing other locomotives, say in an industry switcher or something like that when you're picking up cars. And so it makes it so much easier to run multiple trains. You can run your entire layout and actually feel like you're running your railroad. Now, when it comes to DCC system, there's 5 basic components of the system. There's the cab, or what's known as the throttle, the command station, the power station, the mobile decoder, which is what SoundTraxx makes, and the accessory decoder. We're going to talk about each of those now. So first up is the cab. And go ahead and, there you go. The first up is the cab, and this is what's called the user interface, or this is what takes my desire and turns it into a command to be sent out on the rails. So there's various types, there's wireless, there's wired, and the format and form factor. And there's a lot of different variables as far as ergonomically, how they fit in our hands and so forth. And then there's also different levels of degree of functionality. So you can see that throttle there on the right is what a lot of people call to as an operator throttle, where you basically have throttle, a direction switch, and a couple of functions. Whereas that NCE Pro Cab gives you the ability to do anything you want. And it really just kind of decides by the user what they want to do and how they want to do it. But as far as for me, I love to have the bigger throttle, the more comprehensive throttle, because our decoders have 28 functions. And so I want to be able to use them. And that operator throttle won't be able to do it. So you kind of have to take that into command or into consideration when you're trying to decide on your command station and what you want your layout to operate and how you want it to operate. And so each user operator will have its own command, its own cab, and it will basically be the user interface. It takes your desire and turns it into a command. Now, that is then sent to the command station, and the command station takes your input and turns it into a digital signal to send that command out to the world or your layout. And typically you're going to have one command station per system, because if you have multiples and they're all sending out commands, all these ones and zeros are going to get jumbled, and the decoders are not going to be able to interpret the command or what it's supposed to do. So you have one command station per system. Now, next up is what's called the power station, also known as the booster. And this takes the digital signal that was generated by your command and amplifies it. And this will then take it to broadcast it out on the main line. Now, a lot of times this is built into the command station. And in some cases, like, for example, I know some of us use the NCE Power Cab That's actually has the throttle, the power station, I'm sorry, the throttle, the command station, and the booster all built into the throttle. So it really just depends on the system that you choose. But a lot of times the booster or the power station will supply things like short circuit protection to protect against shorts, to make sure you don't damage anything, voltage regulation to monitor to make sure there's no voltage spikes or anything, and then auto reversing. I know CVP Products has a great booster that has auto reversing built into it, where you can go into a balloon loop and come back out, and the booster will automatically take care of it in that particular section of the layout. So it actually works really well. So that signal is then broadcast out and then comes into the mobile decoder. And this is the decoder's, the locomotive's brains. And so anyway, we're going to take the the command that's being sent out, interpret that command, and then do what the command tells it to do. So basically, this is where the DCC system will tell the decoder to run the motor, turn on the lights, blow a whistle, or whatever the case is. And that command has been sent out by the booster. Now, the decoder is typically the thing that you'll see inside the locomotive. It has a unique address or an ID code, and we'll get into the details of how all this stuff works together in just a moment. So the booster will send a command to a specific ID, and then the decoder interprets it. Now, all of the SoundTraxx decoders are considered mobile decoders, and this goes even with our non-sound motor decoders, the SoundTraxx sound decoders, even factoring in the Blue NAMI, which is basically following this to a certain extent, but through a different protocol. And I know we're going to have another presentation on that at a future date. So the next slide will show you just some pictures of the SoundTraxx mobile decoders. While I love giving out information, I am also a salesperson, so I'm going to throw some different little things like this out. We make a wide variety of different formats to fit your models, depending on what you're looking at. And so we have different formats and different things, different functions, ratings, stuff like that. So pay attention to those things. And we try to make them all as affordable and comprehensive as possible. Okay, end of infomercial. All right, on to the presentation. So next up, we have our accessory decoders, and these are things that will sit along, follow the DCC signal, and can do things like throwing turnouts, illuminating signals, turntables. You can even light up, I know NCE has a thing called Light It, I believe it is, that takes the DCC command, and I can actually turn on and off lights using my DCC controller. And it can be like a factory light or an engine house light or whatever the case is. So all of these things come together. And so here's the next one, has a drawing, kind of show you how all this works. So we take our cab, our user interface, and we push the buttons to tell the decoder what to do. That command is then sent to the command station. It turns into the digital DCC command, which is then sent to the booster, where it's amplified and broadcast onto the track. Then the decoder interprets that command and performs the task as it's told. Now, every decoder or every command has a preface with an address. And if the decoder is not set to that address, it ignores the command and moves on to the next thing. So when we look at our DCC track signal, this is where we're going to get a little technical here, but not overly technical. So a lot of people will tell you DCC is actually AC, and it's not. It's what's called a bipolar DC, and the DC is a square wave, like you see there in the illustration. An AC would be more of a sine wave, kind of like an ocean wave. And the reason it's done this way is because internally, the decoder takes that negative pulse below the mean there and inverts it. And because it's square, now it creates that power source that it uses to light the lights or to run the motor or whatever the case is. And so it's actually a bipolar DC signal. If it was AC, then during that inversion process, there would be losses of power as the power goes from top to bottom. But anyway, that's the technical part of this. Now, the duration of these pulses of power indicate whether it's a 1 or a 0. And the series of 1s and 0s are interpreted by the decoder as a command. So think of it this way, and this is where DCC is standardized, because these 1s and 0s are formulated in a specific way to make sure that the command is sent properly. So if you know, there's other ones, systems out there, like I think it was MTH did their DCS system, which is very similar to this, but the ones and zeros are formulated in a different way. And so basically the way NMRA DCC is following this specific protocol to make sure that when the decoder receives the command, it can understand that it's supposed to eat more Ovaltine as opposed to something else. And I hope you guys got that joke. So anyway, but you can see that these are sent out very fast, very reliably, and so forth. So let's get into the DCC command itself. So the next slide, there's actually 4 parts of a DCC track signal packet. There's the first part, which is the preamble. And the preamble basically says, hey, everybody, listen up. At this point, all of the decoder's ears perk up because they know a new command is about to be sent out. So, hey, everybody, listen up. The next part is what's called the address byte. And in this case, the DCC system says, hey, everybody, listen up, loco 1000. At that moment in time, the address 1000 is being broadcast. Any decoder that is not set to address 1000 goes back to sleep, ignores the the transmission, and goes back to doing whatever it was doing. So next up, we have the instruction byte. Hey, everybody, listen up. Locomotive 1000, move forward, speed step 10, turn on F1, turn on F2, turn on F4, or whatever it is. And that's where the decoder is told what to do. And then the last part is what's called the error detection byte, but it's basically end of transmission. So, hey, everybody, listen up. Loco 1000, move forward, speed step 10, turn on F0, turn on F1, turn on F4, end of transmission. When the decoder receives all 4 packets, or all 4 parts of this packet, it then does what it's told. And this is where your decoders are going to vary by their intelligence, because as I mentioned, you noticed I didn't say, hey, turn on your headlight, turn on your bell, and turn on your cylinder cocks or whatever. I said, turn on F0, turn on F1, turn on F4. It's up to the decoder to decide what those commands are telling it to do. And so this is where there's a part of our decoders called function mapping. And that's what tells the decoder what to do. So let's look at this packet. So if we move forward, speed step 10, it's pretty straightforward. Go back one more. I'm not quite finished with the other one. Move forward, speed step 10 is pretty self-explanatory. It tells the decoder to move its motor at speed step 10 forward. But if we say turn on F0, the decoder says, well, what does that mean? So it looks into its function mapping and it's looking through and it says, I'm supposed to turn on my headlight. All right. Then it looks at the other settings that you've done. What is the headlight supposed to look like? What does the display look like? Oh, okay, I'm supposed to do a dyno light, which is a gradually increasing light in conjunction with the sound of the dynamo. Okay, at how bright and everything. And it goes through this checklist. And then once it goes through the entire checklist and decides what all it's supposed to do, it then illuminates the light. Same thing with F1. What am I supposed to do? I look through, oh, I'm supposed to turn on the bell. Which bell recording do I play? Oh, I'm supposed to play bell number 25. Okay, at what volume? Do I add any reverb? And the decoder does this so fast. The good news is it takes me a whole lot longer to explain it than the decoder actually does. But when you push those buttons, that DCC command comes out and sends that information out, and the decoder performs the task. Now, the last thing I want to point out, this DCC command is one way only. It is a broadcast. So much like a radio signal transmission off of the top of the hill, the DCC system has no idea nor cares whether the decoder ever got the command. It's repeating the command out there. So if your decoder's off the track, your system's not going to perform any different. It's not going to pause waiting for this response. Same thing, your decoder's not going to do anything to send an information back to say, check, got it. Nothing happens. The decoder just does what it's told and moves on. And the reason I point that out is because that helps with troubleshooting. A lot of people attribute more complex communication to this information here than what it is. So we'll go on to the next slide here. And that's basically kind of what the DCC signal looks like on the rails. You can't take a typical multimeter and hook it up on the rails and be able to see what the decoder is supposed to be doing. And I think that's part of why a lot of people get scared of it, because you can't read a DCC signal unless you have the special coding. And so you kind of have, you know, back in the days of DC, we could put a meter on the track and see that a motor's turning or if a model's supposed to be running, but now you can't really do that. So I think it makes a lot of people apprehensive. There's special tools that you need. And like I said, RMS multimeter to be able to read the dual wave DC. The oscilloscope can actually see this. And then Tony's Train Exchange makes a product called an RR amp meter, railroad amp meter, that you can actually hook it up and use for the RMS voltmeter, but it still doesn't decipher the signal. So, but I want to cover really quickly here some of the terms that are out there, because there's a lot of misunderstandings and things like that. Yeah, Jerry, you can turn the slide. There's a lot of terms out there that can be misleading. And so as long as we have the foundation of understanding of how the DCC works, that's it. There's no more mystery to it than what we just talked about. So let's talk about some of the terms here. So the first one up, people hear is configuration variables. And a configuration variable allows you to vary or change the configuration or the setup of the decoder. So it basically it allows you to tell the decoder how to behave and how to do what it's supposed to do. So going back to when we were talking about the bell, a configuration variable tells the decoder to turn on the bell when an F1 command is sent. Then there's another configuration variable that tells the decoder which bell recording to play. There's another configuration variable to tell it what volume to play it at. And then there's another one to tell it if you're adding reverb or echo or any of that sounds to it. And so all of these configuration variables allow you to make adjustments and changes to the performance of the decoder. So a couple of things. There are some that are fairly industry standard. The NMRA defines those as recommended practices. Things like address CVs. There's CV29 is an overall configuration and so forth. So there's some that are fairly standard, but a lot of them are manufacturer specific, and then not all decoders support all CVs. Because, for example, like we have a feature called FlexMap function mapping, where the CV number is assigned to the effect, i.e. the bell, and the value of that CV corresponds to the button that turns it on and off. So if we have that feature is unique to SoundTraxx, there's no standard CVs for it, and no other brands offer that particular type of feature. So we can't really have this one size fits all type of configuration variables. So this is where I'm going to highly, highly recommend using the user's guides for your respective decoders, preferably SoundTraxx, but because the user's guides are going to explain how all the CVs work and what their purposes are. And so the CV is typically assigned a number, and then that number tells a particular part of the decoder how to behave. So when we look at the next slide here, we look at the structure of a CV, and the CV structure is going to be exactly the same no matter which CV you're looking at, no matter which brand you're looking at. The CV structure is going to be the same. Jerry, you can go ahead and turn the next slide over. There you go. And this is also another part where I think it's kind of makes people a little nervous, because now we're talking about bits and a CV value and this kind of stuff. And what does all this mean? And in my opinion, take it for what it's worth. I sell it for the same price. This is the part of DCC that was unfinished by the engineers, because we as the users should never see the architecture of this. And the problem is that when the engineers designed all this, they got together and said, yep, makes sense to me. Great. All right, we got a product. Instead of bringing the marketing people in to kind of hide this from us. But it's an unfortunate thing that we have to know this, but it's not as difficult as it looks. So each CV is a structure of 8 individual bits, numbered bit 0 to bit 7. Each bit has a value or a weight to it. And when you want the particular bit on, you put a 1, and then you add its total to the value in the CV. If you want it off, you put a 0 and you skip that value. And the thing is that all CVs are structured exactly the same way, and you can create a unique number between 0 and 255 using these numbers. If you look at the pattern, every number doubles. 1, 2, 4, 8, 16, 32, 64, and 128. And you can create any number using these numbers, and that number then tells the decoder how to behave. Now, some CVs are a percentage. So when you look at volume percentages, for example, 0 to 255 equals 0 to 100% volume. There's other ones where individual bits will do specific things to tell the decoder how to behave. So like, say, for example, when we go into our Steam decoder, CV112, a combination of bit 0 and bit 1 determine which type of fuel sounds are active, whether it's a wood burning locomotive, hand shoveled coal, auger fed coal, or oil fed. And a unique combination of 1 and 0 in those two bits tell the decoder which sound to play when that sound comes up. So for example, firing or fireman Fred using his shovel or throwing wood into the wood fire. And so each bit may vary. And that's why I say, again, use the user's guide, because most of the time our user's guide will walk you through, hey, if you want this sound, start with a value of 3. If you want a lifting injector, then add 8. If you want this, then add 16, or whatever the case is, and it works its way through the structure. But anyway, that's kind of the most technical part of this whole thing. And if you take your time, one of the things SoundTraxx has done is you cannot break a decoder by changing a CV value. Trust me, I've tried. As part of my job, when we have new software, I get to sit down with a book that's about 1.5 inches thick, and it's CV by CV, value by value, one at a time. And I have to test everything out to make sure everything works. And I'm one of about 3 people that do this test. And if one of us finds a problem on the last page that the software engineers have to address, guess what? We get to start all over again, because they fixed something, they could have broken something else in the software. And this is kind of the thing that we do to make sure. So like, say, for example, on our Steam decoders, again, we have 90 whistles to choose from. If you try to choose whistle number 92, in some brand decoders, it would then put you in a perpetual loop, because it's trying to find that data that doesn't exist. So the decoder can't do anything until it gets that data. Our decoders have a safeguard built into it so that if you try to pick whistle number 92, it says, that's not a valid choice. And so it defaults you to whistle value 1. So that way you cannot break the decoder by changing CV values. Now you can get some odd behavior or unexpected behavior, but you didn't break it. So changing CVs, this is the other part that I really want to cover. There's 2 methods for changing CVs here. One is what's known as service mode, which is putting it on a programming track. And then you have operations mode, which is programming on the main or on the fly. And so let's break down both of these. First off is service mode programming. Service mode, when I talk to customers all the time, I'll ask them, okay, they say, I have a decoder that's unresponsive. Okay, can you put it on your programming track? Yes, it's there. Well, I can hear it. Yeah, it's on my programming track. Let's make sure we understand what we're talking about. Programming track protocol is what I'm after. A lot of people will have their main layout that they operate and run their trains, but then they have a separate DCC system that's set onto a test track that they call their programming track, that they use to test their locomotives and set CVs before they put it on the main line, on their railroad. And so those are different, because the programming track protocol is actually slightly different. So when we go back to our DCC command, programming track command is, hey, everyone, listen up, set CV 29 to a value of 34, end of transmission. Did anybody see something missing? There's no address command. And so if the address command is not there, then the command goes out to all decoders regardless of address. And this is why programming track protocol is important, because it allows us to regain control of our decoder without having to worry about remembering the address. Because let's say we're going in there and typing a CV, and let's say we just fat finger it and hit a wrong button. Oops, now my decoder isn't responding anymore. Okay, well, we can recover it on the programming track because the protocol doesn't require me to have the address. So it allows me to reset the address without knowing it. The other thing that we can do, of course, we can set CVs all day long on our programming track. But one of the other things we can do is read CV settings. And reading a CV is not done the way you think it would. Most people would assume the DCC system says, hey, decoder, what's the value in CV29? And the decoder goes, 6. Nope, that's too complicated. What happens, remember when we were all kids and we played the game 20 questions? This is a game of 256 questions, starting with, hey, decoder, is the value of CV29 0? When the decoder answers no, nothing happens. So then the system moves on to the next question. Hey, decoder, is the value of CV29 255? Those are the two most common values. Nope. Okay, is it 1? Is it 2? Is it 3? Is it 4? Is it 5? Is it 6? When the decoder answers yes, the decoder draws current. Prior generations would draw it through the motor circuit. Our Tsunami 2 Economies now draw it through internal circuitry. But when the DCC system on this isolated controlled programming track senses that change in current, aha, we have a yes answer. Displays it in the window, CV29 equals 6. And so that's why you have to have this dedicated, isolated programming track set up, because it allows you a controlled environment where you can communicate a little bit more explicitly with that one decoder. You cannot read on the main line, because if you're trying to read on the main line, let's say Dale's on the other side of the track and starts running a train, the DCC system has no idea where that change in current came from. All it sees is a change in current, and so you're going to get an erroneous read. Now, the big thing about this is because service mode programming is there for just servicing, you cannot test your settings in service mode. And this is why I want to separate it between your programming track and your test track, because programming track is just for that, programming. You put the decoder on the track, you go to programming track mode, your decoder should go quiet. Now, the other thing to pay attention to is there are some systems out there that have the main line and programming track as the same physical outputs. And so this is why you have to know your DCC system. So make sure you read the manuals. The NCE power cab that I mentioned earlier, the same wires going out to the main line also serve as your programming track. And so make sure you understand the difference between the two. Next up is operations mode. This is programming on the main line. You can program on the main line. I know a lot of people like to argue with me, but here's the thing. Let's go back to our DCC command. Hey, everyone, listen up. Loco 1000, set CV 128 to a value of 255, end of transmission. How many decoders are going to respond to that command? 1, address 1000. So when you're programming on the main line, you have to know your decoder's address to be able to program it. If you don't know, that's where you go back to service mode. The reason I point this out is I think a lot of people, when I mentioned the last thing there on the last slide, some DCC systems have the same outputs for a programming track as they do your main line. So what happens is you get into this club environment, and for some reason, the DigiTrax DCS 200 has that. And so what happens is that when Bill goes over in the corner and he just starts typing away on his throttle because he's programming, the layout shuts down because there's no sound. Everybody's looking around for the short, trying to find the short circuit. Well, Bill's done. He has no idea what's going on. He's done. He hits exit. Layout comes back up. Everybody assumes they found the short. Next thing you know, they all try to run their train, and Bill's the only one running trains, and all the trains are responding because he didn't know that that was a separate programming track that you have to throw a toggle switch. So that's where I believe that myth came from. But you can program operations mode. I do it all the time. I do it on layouts. I just don't tell anybody because the command is done this way. Hey, everyone, listen up. Local 1000, program CV X to Y, end of transmission. Only the decoder that has that address is going to respond. Same way it does. It's no different than blowing a whistle command. Now, the advantage is that you can immediately see the results. You can instantly see that change or hear that change on your decoder's behavior. But you cannot read, as I mentioned before. So the last few slides here, I'm going to go through pretty quickly because I'm running a little long and I apologize for this. But function outputs, lighting effects, things like that that you can turn on and run your locomotive to bring more life to it. There's a lot of these are industry standard color coding, following commands. So make sure you pay attention to the diagram that comes with it. Now, when it comes to function outputs versus function control, function outputs is we designate them at FX, basically FX1, which is headlight, FX2 is our reverse light, and then FX3, 4, 5, 6, 7, and 8 are the different lighting outputs that you have access to. Now, when it comes to function buttons, and again, here's where some of the nomenclature could be changed. The next slide is function control. And so that's where you push the button. So function 1 turns on the bell, function 2 turns on the whistle, or function 3 turns on the short whistle, or whatever the case is. And so there's some cross pollination with terms. And again, this is industry thing. It's not necessarily a SoundTraxx thing, but we're following it. And so whenever you're talking with me, I'm going to ask you, lighting output is going to be FX light whatever, or the button is going to be F number whatever 0 through 28. Next up is what's called motor control. Now, a DCC decoder does not control a motor the same way a DC power pack does. A power pack increases the voltage. As the voltage goes up, motor turns faster, train moves faster down the track. A decoder uses what's called pulse width modulation. I'm sure you guys have heard that term, PWM. Think of it as modulating or changing the width or duration of the pulse. And the duration of that pulse is going to dictate the speed. So in a 1 second window, if you're at 10% throttle, you're only going to have that power applied about 10% of that second. And then you're going to see another pulse for 10% of that second. And it increases duration as it goes. The reason this is done is because now back EMF decoders, when the motor's off, it's still turning. And so that's creating what's called back electromotive force, or back EMF. And that's what the decoder uses to create a lot of our sound effects. But the last thing here is stall current. The reason this is important is because when you go from 0 to speed step 1, that first pulse of power goes out while your motor's stopped. And that motor has to start turning before the current draw drops. And that's why you have to pay attention to stall current. So you want to make sure to test the stall current before you pick any decoders. There's a YouTube link there that you can find, or if you go to YouTube, search SoundTraxx and stall current, you'll see a video on a couple of processes on how to do it. Next up is speed steps. And initially, the industry came out with 14 speed steps. Then they refined it and came out with a more refined 28. Now we have 128 speed steps. And I highly recommend everybody going to 128 speed step mode, because you can really make these decoders crawl. Because if you're in 28 speed step mode and you go to speed step 1, you're essentially at step 5 of 128. So you really want to try to make sure that you're using the most refined speed step control. But internally, the decoder has 2048 internal speed steps using back EMF, momentum, things like that. And then we talked about back EMF, what it's done, and the decoder uses that to modify that PWM signal to make sure the motor's turning when you go to speed step 1, and also helps maintain a speed when ascending or descending grades. So the last slide here I have for you, our YouTube channel is filled with a lot of tips and hints about using our products. We post videos every single week. And so therefore, we encourage you to go watch some of these SoundTraxx. Go to YouTube, search SoundTraxx and the topic. Chances are you'll find it, including this webinar here. This is done a little bit more in depth. It's called webinar number 4. So if you search SoundTraxx webinar 4, you'll get to see all this again. And users guides, cannot stress those enough, and other tips at soundtraxx.com. And last thing, feel free to call us, email us. We're here to help you. We're modelers ourselves. We want to make sure you're enjoying your hobby, which is why I volunteered to do this presentation, because I think a good, solid knowledge-based foundation is important to understanding and appreciating and enjoying our hobby. And with that, I'll open the floor.
Thanks, George. That's fantastic. Just what we needed. I do have a couple of comments in the chat. Greg conveniently explained the joke about Ovaltine, so that's from the Christmas story.
Yes, sir.
Ralph's a model railroader, so that's Ralphie rather. Steve Hollenbach's asking, does the DCC system send out a new packet every time you press a button?
Yes.
Yeah, that's what I thought.
Some systems will repeat the command, and some systems will not do anything until you change a throttle setting or something. So it really depends on your DCC system. For example, NCE only sends out repeats motor commands, but will not send out any function commands. Easy DCC doesn't do anything until you change something, but DigiTrax repeats constantly.
Right. And Reiner's asking, can I find out a forgotten locomotive address? How?
Yes, and that's exactly what the programming track is for. So you can put it on the programming track and read CVs. So if you don't remember the address, first thing you do, put it on there, read CV29, and CV29 will tell you which address is active. And then once you know which is active, then you read the respective CVs and then determine the value on it. But some systems will actually allow you to read address as a button or a function in the menu, but you just have to know your DCC system.
John has asked basically the same question. How do you change your loco address? And that you can do on the program.
Correct. You could do the programming track or the main line. And depending on your system, because the decoder itself has a way to ignore changes to the active address when you're on the main line. And the reason for that is it doesn't want you to accidentally change your address. Say, for example, if I was trying to change a lighting effect in CV51, but I didn't press the 5, I hit CV1, I hit 1 and enter. Now I enter a value. I just changed my decoder's address, but in my mind, I was changing a lighting effect. So our decoders will not allow you to change active, but you can change the inactive address on the main line and then activate it by changing CV29. Or you go to the programming track and you just type in the address, follow the prompts, type in the address, and you can do it there. So if you've gone back to the other one, if you forgot the address, but you want to set it as something, just put on the programming track and set the address again, put it back on the main line, you're good to go.
Thank you very much, George.